Hey guys, hey, welcome back. Welcome back to your next installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement. So, new backdrop, same basement, same teacher, but we're coming at you with a little bit more math to try to reinforce some things that we've learned already this year that you're definitely going to be seeing next year. Guaranteed. I bet my minivan you're going to see this again next year. So we're trying to make you as rock solid as we can with these 8th grade standards, so that when you walk into that first day of ninth grade, you are comfortable and confident with the algebra. Because all of you are going to be in algebra next year, and I want you to be as comfortable and confident as you possibly can be for that first day of ninth grade algebra. So, without further ado, we're going to get right into this. I hope you enjoy the new backdrop. We got some pool cues over here, ping pong table top. We got the pool table right here, and we're ready to rock and roll through this. I got my whiteboard, got the marker, you know it, got the magical eraser. What do you think of this magical mustache, huh? Rocking it, right? And of course, got my coffee. No good math lesson without a cup of coffee. So, let's ready to rock and roll. We're going to be solving equations again, just like last week. This time, however, instead of one solution, what if I gave you an equation that didn't have any solutions? What would that look like? Something kind of bizarre kind of happens. What if I gave you an equation that didn't have one solution, it didn't have zero solutions, it had infinitely many solutions, which we abbreviated as IMS, right? And that happens from time to time. Sometimes there's no solution, sometimes there's infinitely many solutions. What do those equations look like? And that's really our objective for today. By the time you finish this video, if you can stay awake that long, you're going to be able to solve an equation with either no solution or infinitely many solutions, which we abbreviated IMS. So if you need to go grab your notebook, grab a pencil. I don't think a calculator is probably going to be needed today. If you want to have it just as a backup, that's certainly fine. But if you need to pause the video to go grab that stuff, also pause the video to get this title down in your notes. That would be great. But this is very much an 8th grade standard. Again, this is just some review from earlier this year, but definitely something you're going to study again in ninth grade. And that's really my objective here in the last about 4 weeks of school, is to really hit those standards that I think are the most foundational, really the rock upon which you're going to build this house of algebra. We need to make sure that rock is rock solid. So we're going to get right into this. One last time, if you need to pause the video, get this down, looking at equations that either have no solution or infinitely many solutions. All right, let me get some space here on my one and only whiteboard using my magical eraser. We're going to get right into this. All right, here we go. The directions on your Google Doc will simply say solve the equation. If there's no solution, say there's no solution. If there's infinitely many solution, say that there's infinitely many. But off the bat, there's two questions I really want to start with. What do you notice? And you've heard these questions 1,000 times this year. What do you notice? And what do you wonder? I notice blank, blank, blank. I wonder blank, blank, blank. And I'm going to give you an equation. Initially, it's going to look like any other equation we've solved, any other linear equation that we've solved, with a couple things that hopefully you take note of. Let's do negative 4x plus 1 equals negative 4x plus 2. What do you notice? What do you wonder? Jot down in your notes. What do you notice? Kind of unique about this. What do you wonder? I notice right away that there's a negative 4x over here And there's also a negative 4x over here. So using some good vocabulary, some good algebra vocabulary, I notice that this coefficient is exactly the same as this coefficient. Again, using some good algebra vocab, I notice that this constant is not the same as this constant. So two observations, two things that I noticed. I wonder, is this going to give me one solution like last week? Is this going to give me no solutions? Or is this going to give me infinitely many solutions? That's what I wonder, and that's what we're going to solve right now. Here's the good news. The steps that you use to solve this equation are no different from last week. We want to get the x term on the same side. So we're going to have to use inverse operations to get this x term over to this side. Kind of that whole 7th grade teeter-totter effect. Since this is minus 4x, let's add 4x. But we have to do it to both sides. So I'm going to do that. You do that in your notebook. Add 4x to both sides. The 4x's on the left side cancel. Oh my stars. They also cancel on the right side. And I get 1 equals 2. Because all the x's canceled, I ended up getting one constant is equal to the other constant. That should look bizarre. That's really bizarre. Why is that bizarre? Because they're not equal. 1 is, as much as it wants to be like 2, 1 is never going to be equal to 2. It's close. They're certainly close to each other on the number line, but 1 will never be equal to 2. This is a false statement, so literally stop trying to solve this because it can't be solved because you got something that's false. So literally you write the word false, and I know we talked about this symbol. It's an equal sign with an arrow next to it. This means therefore. So because we got something that's false, we say therefore there are no solutions. And in math we can use this symbol to represent no solutions. It's called the empty set. So if tonight or today when you work on this Google Doc, I'm going to give you a number of different equations to solve. If you get something that's false, if you get a mathematical statement that's false, stop. Stop trying to solve it because it doesn't exist. A solution does not exist. Trying to find something that doesn't exist stinks. It's frustrating. It's kind of like trying to find a pot of gold at the end of a rainbow. It's not there. It doesn't exist. Same with these equations. Trying to find something that literally doesn't exist is really, really frustrating. So just stop trying to solve it because it's a false statement. There are no solutions. Now, how could you check yourself? How could you check yourself to make sure there truly are no solutions? Pick a number. Pick any number. Pick your favorite number. Whatever your favorite number happens to be. Let's suppose your favorite number was 10. If I plug 10 into my original equation here, and for x, and I plug 10 in here, what should happen? We should get something that's false. Let's try it. So this would be negative 40 if your favorite number was 10 plus 1. This side would be negative 40 plus 2. So we get negative 39 equals negative 38. Guess what? They're not equal to each other. We got something that's false. We should have, because there is no solution. 10, as cool as that number is, and it might be your favorite number, it's not a solution. If your favorite number was 100, it would also give something false. If your favorite number was 3, also false. If your favorite number was like negative 4, good for you. It's still false. No matter what number you put in here, you're going to get something that's false. Okay. What if, let's try a new example. So label this as example 2. Same question that you'll see on your Google Doc, and some of you may have already peeked at it. Same directions or same instructions, I guess. Solve the equation. What if I gave you something that had some like terms that needed to be combined? For example, if I said negative 4x plus 14x equals negative 2x plus 3x plus 9x plus 5. I'll give you a second if you need to pause the video to get this equation down. This looks really long and perhaps relatively more complicated. But you got to use some 7th grade skills here. These two terms are what? That's right, they're alike. So we can combine these together. These three terms over here, this one, and this one, they're also alike. So they can be combined as well. This guy is a constant. He's not like these other terms over here. He cannot be added to these guys. He's an unlike term. So let's combine these two together. Let's combine these three together and see what kind of equation. The work as you move down the page, as always, should get smaller, should get shorter as you move down the page. So this would be 10x on the left side. And when I add those three terms together, negative 2x plus 3x, that's right, that's 1x. But now add it to the 9x, that's also 10x. And then again, the plus 5, it's kind of a standalone. Again, we call it a constant because it doesn't have a variable here. It cannot be combined with the 10x. What do you notice? Same two questions. What do you notice? I noticed that this coefficient is the same as this coefficient. I hope you did the same. I notice this doesn't have a constant over here. Technically it's 0, but this constant is 5. I hope you start to see the pattern kind of forming here. If the left side has a coefficient, the right side has the same coefficient, and the constants are different, it's going to be a no solution equation. Let's try it. If I subtract 10x from both sides, you guessed it, the 10x's are going to cancel each other out. I get 0 on the left side. And on the right side, I just bring this 5 straight down. And I get 0 is equal to 5. And false. That's right. 0 will never be equal to 5. So again, you can just stop. There's no reason to keep trying to solve this because it can't be solved. You would simply say false. There are no solutions. The answer is there is no answer. So on your Google Doc tonight, if you get to an equation that gives you something that's false, just stop and put no solutions. Are we good on no solutions? Perfect. All right. If you do have questions at any point, please email me. Please email me. I'm here to help. As always, I've been saying it for the last 2 or 3 weeks. Email me if you have questions. That's a big part of my job, is to help you better understand this. If you don't quite understand a particular problem, email me and I will respond as quickly as I can and hopefully shed some light on your question. Love coffee. All right, let's move on. What if, we're going to call this example 3, same instructions, solve the equation. What if I gave you something that looked like negative 5x plus 7 equals 7 minus 5x? A little bit trickier. Now over here on the left side, the coefficient is negative 5. The constant is 7. On the right side, I purposefully kind of flip-flop the order here. The coefficient is always the number in front of the variable. Always. The coefficient here is not 7. The coefficient is technically negative 5. Whatever symbol is in front of a number goes with that number. So the number in front of the x is negative 5. That's the coefficient. Notice it's the same as this coefficient. The constant over here on the right side is positive 7. There's technically a plus sign right here. It's positive 7. Guess what? It's the same as this constant. Different pattern, right? Coefficients are the same. Constants are the same. you can probably guess something kind of unique, something kind of funky is going on here. If I go to solve this and I add 5x here, teeter-totter it over here, if I add 5x over here, what's going to happen? They're going to cancel. Let's do that. And I end up with 7 equals 7. Wow. 7 equals 7. Guess what? That's true. 7 will always be equal to 7. And at that point, stop. There's no reason to keep going except this time. Don't put false. This was very much true. So we got a true statement. Therefore, what? That's right. There's infinitely many solutions now. If you get a true statement, stop working. Just put the word true. Therefore, infinitely many solutions. And you can just abbreviate it on your Google Doc. I'll know what you're talking about. You can just abbreviate it IMS for infinitely many solutions. You should move relatively quickly through the assignment today. Most of the problems are either no solution or infinitely many solution. And by the way, same thing. If you want to check it, pick any number, literally any number on the planet. If you plug it into the original problem, which was negative 5x plus 7 equals 7 minus 5x, pick any number. If I plug it in here and here, guess what should happen? That's right, both sides should now be equal to each other. So let's say your favorite number was 1. We'll just keep it real straightforward. If your favorite number was 1, and I plugged it in for x, so right now I'm just checking the work. So that'd be negative 5 plus 7. This is 7 minus 5. Guess what? Both sides are equal to 2. That's right, they're both equal to 2. So that tells me that infinitely many solutions is the correct answer. The answer is there's a whole bunch of answers. Any number, any real number on the planet would work. All right, let's move quickly. I'm trying to keep these videos a little bit shorter than they have been because I know you guys got a lot to work on. Let's try another kind of multi-term problem. Two n plus 5 plus 31n equals 7 minus 2 plus 27n plus 6n. Couple things to notice. Number one, there's two terms over here that are alike. Combine those together. How many n's do you have? That's right, you got 33 n's plus 5 on the left side. Again, these cannot be combined. These are not like terms. Now let's start combining like terms over here. These two guys can be combined because they're both constants. That's 5. And then the last two are also like terms. They can be combined. That would be 33n again. Wow, that's exciting. So we got same coefficient and the same constant. Same coefficient, same constant. You know what's going to happen. It's going to be infinitely many. But let's just verify it. If you subtract 33n from both sides, you get 5 is equal to 5. This is so exciting, I can barely stand it. I got something that's true. 5 is equal to 5, so therefore I am S. Again, you should move really pretty quickly through this assignment. All right, last one, then we're going to look at a story problem, and then I'm going to stop talking so you can get started on the assignment. What if, same directions, I think we're on like example 5 now. What if I gave you something look like this? 9x plus 3 equals 3 times the quantity. 3x plus 1. Whoa. Solve the equation. What do you notice? Same questions as always. What do you notice? I noticed right away that this looks weird, right? This right side looks kind of weird. But I wonder, what property could I use over here to make it look not so weird? That's right. If there's a number on the outside and 2 or more terms on the inside, it's the old bread and butter property from like 5th grade. It's called the distributive property. That's right. We're going to distribute this 3 here and then distribute the 3 there. Remember using the arrows all this year? So it looks something like that. And again, keep in mind, there's really a dot right here, so we're multiplying. So let's go ahead and distribute. I'm not touching the left side right now because those 2 terms cannot be combined, but I can distribute this 3 on the right side, and I get 9x plus 3. At this point, if you've been paying attention and awake for this whole video, you've probably noticed that, again, the coefficients are the same, the constants are the same, so we should get IMS. But let's verify. If I subtract 9x from both sides, I get 3 is equal to 3. That is very much true. Therefore, IMS. Alright, so that kind of takes us to the end of the no solution problems and the end of the infinitely many solution problems. Again, most of what you're going to see tonight or today is that kind of general format or that general pattern to recognize. I want to end with a story problem. You're not getting away without looking at a story problem. So let's look at 2 cars. You guys are close to being at a point in your life where you're going to be driving here soon. So let's look at 2 cars. Let's look at like a convertible and a pickup truck. Okay. Let's suppose, and you're trying to rent these cars. You want to rent these cars. So let's say the truck costs $10 plus 50 cents per mile. So the rental car company says, yeah, you can rent this truck. It's going to cost you $10 plus 50 cents for every mile you drive. All right. That's option 1. You can get a rental truck. Pause the video if you need to finish writing this down because I'm going to keep moving. You can rent this truck. It's going to cost you $10 plus 50 cents every mile you drive. So if you just take the rental car and sit in the rental car parking lot for a day, it's only going to cost you $10 because you didn't go anywhere. But for every mile you drive, they're going to charge you 50 cents. $10 plus 50 cents per mile. Or you can get the convertible. The convertible is going to cost you $30. Riding in style on a convertible plus 25 cents per mile. So it costs you more up front, costs you a whole lot more up front, but now for every mile you go, you're only going to spend 25 cents. So this one costs more up front, but it costs you less per mile. If we were to graph these, the truck, its line would be going up from left to right. At what slope? If we're measuring miles on the x-axis, let me do a real rough sketch here, get some space. So if we do miles on the x-axis and the dollars on the y-axis, the truck is definitely, the line's definitely rising, right? Gunther would be going up from left to right, and the truck would look something like this. For every mile you drive, your cost goes up relatively steeply, or relatively steep. The car, the convertible, starts higher. It costs you more up front, but its slope is what? it's not as steep, right? Because it's only costing you 25 cents per mile as opposed to 50 cents per mile. So even though the initial cost is higher, its line is going to be flatter. That's right. It's not horizontal. It definitely has a positive slope to it. Gunther is definitely rising, but it's definitely not as steep. So what does that mean? If their slopes are different, but both positive, here's the convertibles line. It started higher but is not rising as quickly, or it's not as steep. They have to cross. And if they do cross, we call this the point of intersection, the POI, or the POI. The point of intersection is the solution. So it's going to cross at some point x comma y. Here's the good news. I'm not going to have you graph these tonight. We've already done that this year. What I want you to do tonight is write an equation that could represent this information and then solve it. So let's try it on this one. Let's try it on this one, and then I'm going to have you try it on your own two cars. Not your own two cars, but I'm going to give you two other cars on the Google Doc, and I'm going to ask you to do about the same type of problem. So let's look at the truck. Let's put the truck on the left side, the convertible on the right side. So the truck we said was $10 plus 50 cents per mile. The mile is the unknown, so I'm going to call it M for mile. So the truck is 10 bucks. If you go nowhere, if you go 0 miles, it's going to cost you 10 bucks. But every mile you drive is going to cost you 50 cents additional money. So the convertible would be what? What's its starting point? That's right, it's 30. But what's its slope? It's not as high, which gave you that like more shallow line. Its slope is only 0.25 per mile. Can we solve this? You betcha we can solve this. And we should get a solution this time. Not like the previous ones in this video where we got no solution or infinitely many solutions. We should get 1 point. We should get one answer or one solution. So let's try it. Let's solve this. This is what we did last week in the video. Let's take the smaller coefficient over here to the other. Notice now, as opposed to the rest of this video, now the coefficients are different. If the coefficients are different, they have to cross. They have to have a point of intersection or a point. All right, let's subtract 0.25 m from both sides. So we get 10 plus 0.25 m equals 30. Hope I'm doing this right. I didn't bring a calculator down here, but I'm pretty confident that's right so far. All right, we're trying to get this m by itself, so let's undo the constant next. Sounds familiar, right? Undo the constant next. So we got 0.25 m equals 20. .25m equals 20. So what symbol's between the 0.25 and the m? That's right, it's multiplication. So we can divide by 0.25 on both sides. Sorry. And I'm kind of out of room, so I'm going to move a little bit. And I got m is equal to 80. What does that mean? That's right, it means if you drive 80 miles in your truck and you drive 80 and your friend drives 80 miles in the convertible, what's that mean about your cost? That's right, they're going to be equal. At that point, that one instant in time, you would both be spending the same amount of money. You'd have to drive 80 miles for that to happen. How can we check it? We could certainly graph it. We can certainly graph it. We don't have the time right now in this video to do that. So we answered the question, when, or technically how many miles when cost are equal. That's technically the question we answered, and we got 80. How many miles till the cost are equal? We got 80. Let's check it. So if we said 50 cents per mile for the truck, plus $10 to rent it, and then the other car, the convertible, was 0.25 times 80 plus 30. So I just plugged in 80 for M. Let's verify. We should get two costs that are exactly the same. Let's try it. So this is 0.5 of 80, that's 40, plus 10. 0.25 times 80, that's a quarter of 80, that's 20. Oh my stars. This is awesome. Math is amazing. We got both sides are equal to 50. Both sides are equal to 50. What does that 50 represent? That's right. That's the amount of dollars. That's the cost to rent the truck for 80 miles. It's also the cost to rent the convertible for 80 miles. At that one moment, at 80 miles, you and your truck and your friend in the convertible will both be spending exactly the same amount of money, which is $50. That is a really, really good problem, and I hope you enjoy doing this problem, very similar problem, on your Google Doc tonight. So at that point, with that, I think we're going to put a pause or a stop to this video. I hope you're still awake. Hope you're still awake, and that's our plan here for the next few videos, is to really, because we're officially done with all of the 8th grade standards, we're going to really rock and roll through some reinforcement, some review for those major players, those major standards in 8th grade that I guarantee you're going to see next year in 9th grade. Again, my goal here in the last few weeks is to make sure that you are rock solid with those kind of key players, those key standards from 8th grade that you're going to see again in 9th grade, so that you are as comfortable and confident as you can be when you walk into that freshman algebra class. So, thanks for tuning in. You guys can go ahead and open up that Google Doc and get started on those. I miss seeing you guys a lot, and I hope you and your families are doing well. As always, be kind to one another. Be kind. Be patient with one another. I know this is some crazy times we're in, but be patient. Be patient with one another, and above all, I know I say it a lot, but I mean it. Above all, please pray. It's very important to pray. Be thankful for what we have been given, the blessings that we do have. Pray for one another. Pray for your families, and everything will be fine. Everything will be fine. And we'll see you guys soon. Have a great day. Thanks, guys.